Hi everyone, this is Farhan guys. Today we are going to discuss about chemistry paper 1 multiple choice question of AS level, February March 2023, variance 12. The duration of this paper is 1 hour 15 minutes. Let's see what we have in this paper. Now the question number 1 is 4 equations representing reactions of nitrogen or one of its compounds are given. Which equation represents a disproportionation reaction? So we have discussed disproportionation reaction in the class, and according to that, if an element exists in two different oxidation states, in a same reaction or in a similar reaction, then it's called disproportionation reaction. All right. So one by one, we need to check. All right. This is nitric acid. This is calcium carbonate. They are reacting together, converting into salt, carbon dioxide, and water. Obviously, it is not disproportionation reaction. Basically, it is neutralization reaction. And you guys know that neutralization is not redox. Okay, so this is neutralization reaction. So we can cancel out this. Now, similarly, let's talk about option C. When any ammonium salt react with any alkali, then always ammonia gas is given off. That's what we have done in the class, along with salt and water. So if it is not a correct answer because it is an acid-base reaction, because ammonium ions are a conjugate acid. Okay, this is acid-base reaction. Let's solve this equation first. Ammonium ions and chloride ions. So let's ionize ammonium chloride. So it converted into ammonium ions and chloride ions. Similarly, we need to ionize sodium hydroxide. It will turn to sodium ions and hydroxide ions. Ammonia won't ionize. NaCl ionizes into its sodium and chloride, and obviously water are not going to ionize. All right. Now the spectator ions cancel out with each other, and obviously spectator ions are sodium ions and chloride ions. So the final equation becomes ammonium ions and hydroxide ions converting into ammonia and water. All right. See, guys, this is your conjugate acid, or simply it is Bronsted-Lowry acid because it is a proton donor. It is an alkali, so it is basically an acid. It is basically an alkali, so it is an acid-base reaction, which is why we need to cancel this option. Okay. Now in option B, nitrogen is diatomic molecule. It is neutral. Its oxidation state is 0, whereas in this ammonia molecule, nitrogen has an oxidation state of -3. So nitrogen is basically being reduced in the reaction. So again, it is incorrect because it is a redox reaction. Why it is a redox reaction? Because nitrogen changes its oxidation state from 0 to -3, whereas hydrogen changes its oxidation state from 0 to +1. Okay, so right answer is going to be D. And guys, we have done this equation in the class. I think this equation is given in your register as well. Over here we have an oxidation state of nitrogen is +4. Over here we have an oxidation state of nitrogen is +5, and over there we have an oxidation state of +3. So see, nitrogen exists in two different oxidation states in a similar reaction, which is why this reaction is called disproportionation reaction. So this reaction follows this definition. Okay, I hope it makes sense to you. Let's move on to the next question. Question number 2. The diagram shows the Boltzmann distribution for 1 mole of a gas. The gas takes part in a reaction with an activation energy EA. All right. So y-axis, we have number of particles with energy. X-axis, we have energy, also called kinetic energy. So which statement correctly describe the effect of an increase in temperature? You guys know that when temperature changes, it changes the shape of the graph. All right. So when you increase the temperature, obviously, this most probable energy should decreases and the curve maximum shifts to the right hand side. So we conclude that this curve needs to be like that. Okay. All right. And from this, conclude that is the proportion of molecule with energy greater than or equal to activation energy. Okay. So let's talk about one by one. Peak P will be higher and fewer molecules, not at all. Peak P should be lower. At high temperature, it should be lower. The most probable energy should be lower. So obviously this is going to be incorrect. This is going to be incorrect. Now the combination exists between C and D. So peak P will be lower. That's right. And a fewer molecules will have lower energy, not fewer molecule. Initially, it was a fewer molecule. If you can see that, initially it was a fewer molecule. See, it was a fewer molecule. Initially, it was a fewer, but after this, it becomes bigger, right? This is the whole chunk that involves in the chemical reaction. So obviously, option C is also incorrect. Let's talk about D. P will be lower, that's right. And more molecules will have energy equal to or greater than activation energy. So that's going to be the right answer. I hope it makes sense to you. And remember one thing, this curve is for higher temperature. Okay. In the next question, that is question number 3, a student carries out 4 experiments to investigate the rate of reaction between 3 grams of calcium carbonate and hydrochloric acid. Okay. Seems like a little bit tricky. We have 4 different experiments, 1, 2, 3, and 4. And all of them have different situations. The first one is in both experiment 1 and 2, calcium carbonate exists in powder form. And the temperature is same, that is 35 degrees Celsius. So surface area is same, temperature is same, concentration is also same in experiment 1 and 2. All right. Whereas in experiment 3 and 4, concentration is lower. And obviously, surface area is smaller because of large chips, because of lumpy size of the chips. All right. Oh. And also, in experiment 3, we have a room temperature. Oh my goodness, that's the most important thing. Room temperature is basically 25 degrees Celsius. That is a 298 Kelvin. Okay. So out of 4 experiment, this experiment has the lowest temperature, which means this experiment has the slowest rate of reaction. So this experiment needs more time for the reaction. So experiments 3 needs more time. The experiments 3 needs more time. Either B or C is going to be the correct answer because this will give you more time. Okay. Okay, let's talk about this. student collects the carbon dioxide and time how long it takes to produce the same volume of gas for each experiment. What could be the correct time for the 4 experiment? So examiner is asking about the time. So yeah, experiment 3 needs more time because it has the lowest temperature among all. And most importantly, you guys know that calcium carbonate exists in powder form. So obviously it has large surface area. Okay. Then they will have higher concentration. Then they will have lower concentration. And then they will have smaller surface area. Okay. See guys, experiment 2 has higher concentration, whereas experiment 4 has lower concentration. So experiment 2 has more rate as compared to 4. So experiment 2 needs less time to complete the reaction. So experiment 2 needs less time. Less time is here and here as compared to experiment 4. All right, the experiment 4 is basically more time. This is going to be the more time for experiment 4 because it has lower concentration. So it has smaller rate of reaction or lower rate of reaction. So I think experiment 1 has the highest concentration with the powder form with a higher temperature. So this reaction is going to complete within few seconds. So I think it has the shortest time, I believe. So I think B is going to be the right answer. I hope it makes sense to you. But remember one thing, the faster the reaction, the shorter the time. Taken to complete the reaction. Okay, I hope it makes sense to you. Let's move on to the next question. Oh, this question seems to be related to Kp. Okay. The table shows the partial pressure in an equilibrium mixture formed by the Haber's process. What is the numerical value of the equilibrium constant Kp for this reaction? First of all, let's write down the Kp expression for this equation. So Kp equation has to be like this. Kp equals to partial pressure of ammonia. Since ammonia has 2 mole in the equation, it's so number of moles needs to be in power over partial pressure of nitrogen times partial pressure of hydrogen. Since hydrogen has 3 moles, so moles needs to be in power. Okay, so let's plug in the values as it is in the formula. Ammonia is 4,000, make it a square, over nitrogen. Nitrogen is 7,000 into hydrogen is going to be 8,000, and it's going to be its cube. So Kp is going to be 4.46 times 10 to the power minus 9. So right answer is going to be an A. That's an easy question, guys. You just need to plug in the values and you'll get the answer. Okay. Okay, let's move on to the next question. A reversible reaction is shown and its delta H value is positive. That means forward reaction is endothermic. Okay. Which change in conditions will move the position of equilibrium to the right and increase the value of the equilibrium constant. Guys, equilibrium constant value depends only one factor, and that factor is temperature. All right. So equilibrium constant value depends only on temperature. And you want to increase the value of equilibrium constant. For that, products needs to be more as compared to reactant. And since the reaction is endothermic, so if we increase the temperature, obviously equilibrium favors towards right hand side according to Lee-Shatter's principle. This increases the amount of product and obviously increases the value of equilibrium constant. And that's the question basically, because he's asking the value of equilibrium constant and also the position of equilibrium towards right. So increase in temperature is basically the most appropriate answer from my perspective. So I think D is going to be the right answer. Okay. So let me write few words here for your reference. First is increasing the temperature. Favors equilibrium. Towards right hand side. Second, once the equilibrium favors towards right hand side, product amount increases. Then reactants, hence equilibrium constant value also increases. Okay. Let's talk about other options. We have 2 moles here and we have total 3 moles here. So according to Lee-Shatter's principle, if you increase the pressure, equilibrium favors towards right hand side, but pressure has nothing to do with the value of Kp or Kc, which is why we need to incorrect A and C. Okay. So either you need to go for B or D. Obviously, मैंने D को जो है वो account में consider नहीं किया because of the fact that if the reaction is endothermic and if you decrease the temperature, obviously the equilibrium favors towards left hand side. This increases the amount of reactant and decreases the value of Kc or Kp. All right, or in the words, decreases the value of equilibrium constant, which is why B is also incorrect. Oh my goodness. The ore bristlemane may be considered to have the general formula. In this general formula, X plus and Y plus are the 2 different oxidation state of manganese in this mineral. What could be the values of X and Y? Okay. So we need to work on it. Let me check. Oops. Wait. Need to work on this, so we need to write this structure again for our reference. Okay. So first of all, barium is found in group 2 of the periodic table, so it has positive +2 charge. Manganese, the quantity of manganese is 1 here. All right. And we need to find out the value of X. So let's consider this 1X because manganese is only 1, or just write X. Okay. Don't make it that much complicated. Just write X plus. Now this is Mn, it has 8. and this is y plus. So we can write 8y plus oxygen found in group 16 of the periodic table, and it has 2 minus charge. So we have 16 oxygen atom. So into 16 plus OH has an overall charge of -1. We have 4 OH, so into 4. Since this 4 mineral is neutral, it has no charge, which is y equals to 0. So this, I'm going to solve this. So ये हो जाएगा आपके पास x plus 8y minus 34 equals to 0. All right. Then x plus 8y equals to 34. Okay. So what we can do is we need to apply one by one these values, and let's see what which option will get 34 is the total amount. Okay. So if I'll plug x and y value in this, will I get 32? X is 2 plus 4 times 8. So 4 times 8 is 32. 32 plus 2 is 34. So the overall is 34 here. I think A is going to be the right answer. Because अगर हमें यहाँ पर total 34 मिला है और हमें इस option से भी total 34 मिल रहा है, so I think it's going to be the right answer. Okay, let's talk about this one. You do 6 plus 4 times 8. So 6 plus 4 times 8 is going to be how much? 38. So obviously it's incorrect. Then 6 plus 3 times 8 is going to be 30. Also incorrect. Then 7 plus 3 times 8. $31. So it's also incorrect. So guys, we need to check the total of 34. So which option is going to be give the 34 overall answer? So A is going to be the right answer because हमें यहाँ से 34 मिल रहा है. Okay. Question number 7. Silicon reacts with a mixture of calcium oxide and magnesium oxide at 1200 degrees Celsius. Which statement about this reaction is correct? Okay, which statement about this reaction is correct? First of all, talk about calcium here. Over here, the oxidation state of calcium is 0 because calcium is neutral. Now, in this compound, we need to find out the oxidation state of silicon. Silicon is, let's suppose, X. Calcium has a charge of +2 times 2 because we have 2 calcium atom in the compound. Oxygen has a charge of -2 into 4 since the molecule is neutral, which is y equals to 0. Then X equals to what? +4. Okay, the silicon over here is 0 because it is neutral, exists in elemental form. Over here, silicon has an oxidation state of +4. So this is basically the increase in oxidation state. 0 to +4 is increase in oxidation state. That means silicon undergoes oxidation. Okay. Okay. Now let's talk about the first option. Calcium is reduced and silicon is neither oxidized or reduced. Actually, silicon is oxidized. So option A is incorrect because silicon is oxidized. All right. Silicon is reduced. No, silicon is oxidized. So option D is also incorrect. Next, magnesium is reduced and silicon is neither oxidized or reduced. So silicon is oxidized. Option C is also incorrect. The correct answer is going to be B. Okay. Now let's talk about B. Why it is correct? See guys, magnesium over here has a charge of 2 plus, and over here it is 0. So magnesium is getting reduced. Plus 2 to 0 is basically reduction. Okay. Whereas calcium remains plus 2. Over here it is plus 2. Over here it is also plus 2. So neither oxidized nor reduced. Okay. Which is why B is going to be the correct answer. In which species is there a lone pair of electron? Oh yes, that's an easy. Right answer is going to be C. Why? So let's open the structure and let's find out. This is CH3. Okay. A carbon has it has no charge. Obviously, it must be a radical here. So there is no lone pair on the carbon atom. Okay. Because carbon found 4 electrons in its valence shell. Let's count those 4 electrons of carbon. 1, 2, 3, 4. So basically there is no lone pair, and therefore A is incorrect option. Okay. In B, let's draw the structure CH3 again, and obviously carbon has a positive charge. Carbon is found in group 14 of the periodic table, so it has 4 valence electrons. Let's count those 4 valence electrons. 1, 2, 3. So again, there is no lone pair on the carbon atom because of this positive charge. Again, it's going to be incorrect. Let's talk about D. That is methane, CH4. Carbon is found in group 14 of the periodic table, which means it has 4 valence electrons, and those 4 valence electrons are involved in the bonding. Let's count them. 1, 2, 3, 4. Again, no lone pair because it has an angle of 109.5 degree, and this shows that it has 4 bond pair and it has 0 lone pair. If there is no lone pair, incorrect option. Let's talk about C. Let's meet the structure of CH3 first. Carbon is found in group 14 of the periodic table. So it has 4 valence electrons. Count them, 1, 2, 3, and this one is 4. Now this negative charge shows that carbon gained 1 electron, and that 1 electron is represented like this, which means this carbon has a lone pair, and therefore C is going to be the correct answer. Okay. Question number 10. Under which condition will nitrogen behave most like an ideal gas? If you need an ideal behavior, obviously you need to follow high temperature and low pressure condition, because under these two conditions the gaseous molecules goes far away from each other, and obviously the attractive forces between the molecules becomes negligible, and also the volume is going to be the negligible volume as compared to the total volume of the gas. So I think we need to go for high temperature and low pressure condition. High temperature is here, high temperature is here, low pressure is here, low pressure is here. So I think B is going to be the right answer. That's an easy question, guys. I think if you remember, when we increase the temperature, the kinetic energy of the gaseous molecule increases. This increases the movement of the molecule, and so the molecules will move further away from each other. And when the molecules move further away from each other, the forces between the gaseous molecule becomes negligible, and that's the kinetic molecular theory postulate. All right. Similarly, if we decrease the pressure, obviously gaseous molecules won't compress. The gaseous molecules obviously are very far away from each other, and so they will experience negligible forces. Also, volume was also negligible. Hence, this situation also follows kinetic molecular theory postulate, and therefore B is going to be the right answer. Let's do question number 10. The equation for the chemical reaction is shown. All substances are in their standard states. Okay, which statement describes the standard enthalpy change of reaction for this equation? Okay, so we need to read one by one. The enthalpy change when a total of 1 mole of product is formed. Total of 1 mole of product is not possible, because over here we have total 7 moles, 6 here and 1 here. So basically we have total 7 moles of product. It is saying 1 mole of product. So that's not basically the definition with respect to this equation, and therefore we cannot opt option A. Let's do B. The enthalpy change when total of 1 mole of reactant is reacted. Guys, total we have 4 moles of reactants, which means it is also not giving the exact definition as per stoichiometric equation, and therefore B option is also incorrect. Let's talk about C. The enthalpy change when 1 mole of water reacts. Basically, 1 mole of water is not reacting in this equation. 3 moles of water is reacting in this equation. Again, C's option is incorrect. And obviously, if A, B, and C, all of them are incorrect, obviously D is going to be the right option. Let's talk about D. Then enthalpy change when 6 moles of hydrogen fluoride are produced. Yes. When 3 moles of water and 1 mole of this reacting together, 6 moles of hydrogen fluoride are produced. So this statement actually reflects the stoichiometric equation, and therefore this is the right definition, all right, for standard enthalpy change of reaction. And therefore D is going to be the right answer. All right. Let's talk about next option. Question number 11. Molten aluminum chloride has a simple molecular structure. Each molecule consists of 2 aluminum atoms and 6 chlorine atoms. Which statement is correct? Okay. All the chlorine atoms in 1 gram of molten aluminum chloride have the same mass. I don't think so. Actually, chlorine atom has 2 different isotopes now. First one is 35 and the second one is 37. So both of them have 2 different masses. The same mass is not possible, right? So option A is incorrect, because same mass is not possible, because we have isotopes of chlorine. Let's talk about the next option. 1 mole of molten aluminum chloride contain this much aluminum atoms. Okay. We have 2 aluminum atom and 6 chlorine atom. So if we have 2 aluminum atom, so let's talk about this stuff. 1 mole equals to 6.02 times 10 to the power 23. Since we have 2 moles of aluminum atom, it's going to be greater than this one, right? So it needs to be times 2. It needs to be times 2. So again, it is incorrect. Let's talk about the other option. 1 mole of molten aluminum chloride contain this much chlorine atoms. Again, 1 mole is always equals to 6.02 times 10 to the power 23 atoms. Okay. Now we have how many chlorine atoms? 6 chlorine atoms, guys. So if we have 6 moles of chlorine atoms, how much amount we have? So we have 3.612 into 10 to the power 24 atoms. and this value actually reflects this value. So I believe C is going to be the right answer because it matches the values. Both the values are matches, right? Okay. Last but not the least, empirical formula for molten aluminum chloride is this. No, this is the molecular formula. If you want to calculate the empirical formula, half it. So half is basically AlCl3. So this is your empirical formula. And obviously this empirical formula doesn't reflect the answer. So it's incorrect, okay? Okay. If this is the molecular formula, if I'll half it, I'll get the empirical formula. So if I'll half it, I'll get AlCl3, that is aluminum chloride. So obviously this is not going to be the empirical formula for AlCl3, which is why D is also incorrect. Okay. Okay, let's do next question. Which atom contains 4 times as many neutrons as lithium atom? There are two different statements. There are basically two different things. The first one, we need to consider 4 times neutrons in lithium. So first of all, check lithium. How many neutrons in lithium atoms? 7 minus 3 becomes 4. And I need 4 times of that. So times 4 karunga, so it's going to be 16. So let's check where we'll get 16 neutrons. 40 minus 20 is become 20 neutron. It is going to be incorrect. 24 minus 12 is going to be 12 neutron. It's going to be incorrect. 31 minus 15 is going to be 16 neutron. It's going to be correct. And 26 minus 14 is going to be how much? 26 minus 14 is going to be 12 neutron. So obviously D is also incorrect. Okay. So only C option gives you 16 neutron. And therefore C is going to be the right answer. Question number 13. Which statement about the first ionization energy of magnesium and neon is correct? Okay, magnesium and neon. Guys, first of all, magnesium is found in period 3 of the periodic table. Neon is found in period 2 of the periodic table. Also, magnesium belongs to group 2, neon belongs to group 18. All right, that's what you need to remember at this stage. So let's draw this first ionization energy from neon to onwards. All right. Let's draw this. This is neon. This is sodium. This is magnesium. This is aluminum. This is silicon. And then phosphorus. All right. So guys, this is your neon. Neon is a noble gas, and all noble gases has highest ionization energies. If you remember, this is sodium. This is magnesium. This is aluminum. This is silicon. This is phosphorus. And that was the, sketch I have given you in the class during my lecture. Okay. So one thing is certain in this sketch, that ionization energy of neon should be greater than magnesium. Okay. One thing is certain. Second thing, examiner is asking about the first ionization energies, right? And ionization energy is basically the absorption of energy for the removal of electron. So ionization energy is always endothermic. That's what we have done in the class as well, right? So option B, process is exothermic. Option D, process is exothermic. So ionization energy can never be exothermic process. It is always endothermic, which means B and D are going to be the incorrect option. Now competition exists between A and C. Magnesium has a greater numerical value. No, magnesium has a smaller numerical value as compared to neon. and therefore A is also incorrect, and therefore C is going to be the right answer. Let's talk about C. Neon has the greater numerical value that the graph shows, and both are endothermic. That's true because ionization energy, either it's first, second, or third, and onwards, all of them are endothermic. Therefore, C is going to be the right answer. Okay. In a sample of pure water, what is the maximum number of hydrogen bonds that one molecule of water can be involved in? So, first of all, there are two things here. Maximum number of hydrogen bonds by using one molecule of water. Okay. I think 4 is going to be the right answer. Um, how come? Let's see. This is your water molecule, and you guys know that oxygen has two lone pair. First one is this, second one is this. So the basic condition for hydrogen bonding is that element should have, oxygen, nitrogen, and fluorine should have a lone pair. So oxygen has a lone pair here. So this lone pair involves hydrogen bonding. This lone pair also involves hydrogen bonding. Okay. And also you should remember that it is slight negative, and these two hydrogens have slight positive charge. Okay. Also, these two hydrogen also forms hydrogen bond. And obviously these hydrogen will involve the oxygen of water. Okay. And this oxygen has slight negative, hydrogen has slight positive charge. Okay. I hope it makes sense to you. So basically we have 4. Now the next is hydrated cobalt to sulfate loses water when heated to give anhydrous cobalt to sulfate. Okay. So first of all, write cobalt to sulfate, COSO4 dot XH2O is going to be this. Plus water. Okay. All the water of crystallization is lost to the atmosphere as steam. Okay. When 3.10 gram of hydrated cobalt to sulfate is heated to constant mass, loss in mass is 1.39 gram. So this is the mass of water. Mass of water lost. And this is the mass of sample. Okay. So if I'll subtract these two values, I'll get the mass of anhydrous cobalt to sulfate. So let's find out that. Mass of anhydrous cobalt to sulfate. So the mass of sample is 3.10 and mass of water lost is 1.39. So it's going to be how much? Let's calculate this. It's going to be 1.71 gram. Okay. All right. So we know the mass of water. We know the mass of anhydrous cobalt to sulfate. Let's find the value of X from here because he's asking the value of X. And it needs to be the nearest whole number. Okay. So, okay, fine, no issue. This is cobalt to sulfate. Its mass is 1.71 and mass of water is 1.39 divided by 18, which is the AMR of water, divided by 155, which is the AMR of cobalt to sulfate. And guys, you need to calculate this MR at your own because it's not given in the question. And for that, you need to refer the periodic table. Okay. So from here, just give me a second, okay? Just give me a second. Just give me a second. One point seven one. 1.71 divided by 155. So it's going to be 0. 0.011 moles, and 1.39 divided by 18 is going to be how much? 0.077. Now 0.011 is the least value. We need to divide in order to get the simplest ratio. So it's going to be 1, and divided by 0.011 is going to be, I think, 7.02. So 7.02 is going to be C. Okay, I hope it makes sense to you. Oh, question number 16. The table shows bond energies for some diatomic molecules. Deuterium is an isotope of hydrogen. All right. Which statements are correct? So one by one, we need to follow the statement. Diatomic molecule have exact values for their bond energies, which are always positive. So bond energy is always endothermic. So this part is correct. And obviously, these are the diatomic molecules. These are the diatomic molecules, okay? And obviously, with these molecules, there is no other element, which means these are the exact values. Okay, so this is also correct. So statement 1 is correct, okay? And the second statement, the trend in group 7 bond energies can be explained by the variation in instantaneous dipole-induced dipoles forces. All right. I have a very strong reservation on this statement because it needs to be group 17 instead of group 7. Let's see if there is any changes in the periodic table in Feb March paper. I don't think so, but I'm surprised. Yes, there is no changes. It is group 17. So it shouldn't be group 7. It needs to be group 17. So it's all right, no problem. That's not a big deal actually, because bond energy values has nothing to do with the instantaneous induced dipole-dipole forces. All right. In fact, the melting and boiling point depends on these intermolecular forces, not on the bond energy values. So statement 2 is incorrect. Okay. Why I'm saying this? Let me show you. During the theory classes, I've told you a trend. And the trend was, when we move from fluorine to iodine, number of electrons increases. If number of electrons increases, obviously instantaneous dipole induced dipole forces also increases. To overcome such forces, we need more amount of energy, and therefore they have high melting and boiling point. All right. Okay. Whereas the bond energy values of these halogens decreases, which is why the explanation doesn't reflect the bond energy values, which means the bond energy values has nothing to do with these instantaneous dipole induced dipole forces, and therefore option 2 is incorrect. All right, let's talk about option 3. In option 3, a value for the enthalpy change for the reaction between deuterium and chlorine can be calculated using these data alone. These data alone between deuterium and chlorine. So let me write the equation. We have deuterium, which is D2. We have chlorine, which is Cl2. When you will react together, you will get 2 moles of DCl. Okay. Now we know the value of D2, which is 442. We know the value of chlorine, which is 242. all right? But we don't know the value of DCl, which means we cannot find the value of enthalpy change for this reaction, okay? So it's not possible to find the value of enthalpy change for this reaction because in the data, we have not received any DCl value, which means this is also incorrect, and obviously A is going to be the correct option, okay? Question number 17. Two procedures are described. Sulfur is burnt in an excess of oxygen. When sulfur is burnt in an excess of oxygen, obviously it will turn to sulfur dioxide. Okay. And then NO is added to the product mixture. Okay. In the atmosphere, NO reacts with oxygen to give nitrogen dioxide. Now, if I'll introduce nitrogen dioxide with the product mixture, which is sulfur dioxide, obviously NO2 oxidizes sulfur dioxide into sulfur dioxide and reduces itself. So this reaction takes place in the atmosphere, okay? That's what we have done in the class, by the way. Sulfur is burnt in an excess of oxygen. So this reaction will remain same in the second part of the statement. And then NO2 is added to the product mixture. This will remain same again. It doesn't make any difference actually. Let's see what he is going to ask. Sulfur dioxide, and if I'll introduce NO2 directly, obviously this NO2 will serve as a homogeneous catalyst. It oxidizes sulfur dioxide into sulfur trioxide, which will later on will form acid rain and reduces itself. Okay, so this is going to be the homogeneous catalyst after some time because of these two chemical reactions. Okay, which procedure will produce some sulfur trioxide? Some sulfur trioxide. Some sulfur trioxide is from this I can find the sulfur trioxide. From this I can find the sulfur trioxide is which means that both from statement 1 and statement 2 I'll get some amount of sulfur trioxide. I think A is going to be the right answer. All right. Oh my goodness. Powder P is a mixture containing 2 AgCl, 2 of AgCl, AgBr or AgI. P is shaken with dilute aqueous ammonia. A yellow solid Q remains, and that yellow solid is basically AgI. So Q is basically AgI. Okay, and the next part, the mixture is filtered and Q was washed and dried. The filtrate is collected and treated with aqueous nitric acid to produce a white precipitate R, which is filtered off, washed, and dried. Okay. And this white precipitates indicates that R is basically AgCl. All right. Q and R are warmed separately with concentrated sulfuric acid. That's the next level statement. Because if concentrated H2SO4 reacts with AgCl, in fact, chloride ions from AgCl, to be very specific, chloride ions from AgCl will turn to mist fumes of HCl. The concentrated sulfuric acid is not going to oxidize chloride into chlorine. It will turn to misty fumes of HCl. Okay. On the other hand, If concentrated sulfuric acid is reacting with iodide in silver, it will oxidize into iodine. And if you'll get iodine, obviously it has a purple, violet color. Okay, so purple or violet with Q, and Q is basically what? This is your R and this is your Q. So Q is what? Purple or violet color. Okay, so Q is basically iodines, and iodines are readily oxidized into iodine, and this will give you violet color or purple color. So violet is given in A or and B, which means either A or B will correct. Obviously, C and D is incorrect option. Whereas R contain chloridines, and chloride gives misty fumes of HCl. So misty fumes is also called steamy fumes. Steamy fumes is here, steamy fumes is here, and obviously B is going to be the right answer. That's interesting question, guys. Oh my goodness. All right. Two period 3 elements, X and Y, burn separately in oxygen to form solid oxides. The oxide of X is insoluble in water. Some of the oxides are insoluble. Regarding to period 3, two period 3 elements are insoluble in water. The first one is aluminum oxide, guys, and the second one is silicon dioxide. Both of them are insoluble in water. So X is insoluble in water, so X can be aluminum, X can be silicon dioxide. So we need to sort that out, which is going to be the correct one. Let's read the question again. The oxide of Y dissolves in water. Okay. So X either can be aluminum or silicon, but Y is something that is soluble in water. Soluble in water to form a solution which dissolves the oxide of X. Oh my goodness. Okay. What could be X and Y be? If aluminum is X, it forms aluminum oxide, which is insoluble in water. The first part of the question is correct. And the second part of the question is the oxide of Y. The sodium can form sodium oxide. It is soluble in water, giving you sodium hydroxide. And this sodium hydroxide can react with aluminum oxide because aluminum oxide is an amphoteric oxide. So guys, that means A is going to be the right answer. That's easy. Let me explain it again for your reference. Okay, let me explain it again. Y is sodium. The sodium forms an oxide which is called sodium oxide, and that's your Y. Okay, oxide of Y. Okay, is dissolved in water, so it will give you sodium hydroxide, which is a strong alkali. Now, if aluminum is X and it forms aluminum oxide, you guys know that it is an amphoteric oxide. An amphoteric oxide can react with sodium hydroxide, and if it reacts with sodium hydroxide, obviously it will give you sodium aluminate. Okay, which means this is going to be the correct one. And therefore A is going to be the right answer, but let's talk about B, C, and D option as well. With B, if X is magnesium, it will turn magnesium oxide, and magnesium oxide is soluble in water, giving you magnesium hydroxide, whereas it says insoluble in water, which means B is incorrect. If X is silicon and it forms silicon dioxide, it's an acidic oxide. phosphorus is Y, and the oxide of phosphorus is P4O10. This P4O10 and this both are acidic oxide, and these acidic oxides can not react together. And C is also incorrect. Okay. Next is D. The oxide of silicon is silicon dioxide. The oxide of sulfur is either sulfur dioxide or sulfur dioxide. And again, there will be no reaction because both of them are acidic oxides, and acidic oxides cannot react together. I hope it makes sense to you. Okay. Let's do question number 20. Which road describes the structure and bonding of SiO2 and SiCl4? Guys, we have done this in detail in class. SiO2 exhibit covalent bonding. And it has a giant molecular structure. Whereas SiCl4 exhibit covalent bonding and has a simple molecular structure. So simple covalent bonding, giant and covalent bonding. So right answer is going to be B. Okay. Oh my goodness. Okay. A sample containing 0.010 moles of anhydrous calcium nitrate is heated strongly until it fully decomposes. Okay. So let's talk about the decomposition of this. Calcium nitrate decomposes into calcium oxide, nitrogen dioxide, and oxygen gas. Okay. We can make it for 2 moles as well, and it doesn't make any difference in the overall answer. But let's make it simple as much as we can. All the gas produced is collected and its volume measured at room condition. What is the volume of gas produced? We have 2 different gases here, so we need to find out the volume of both the gases. So first of all, guys, it is 1 mole and it has 2.5 moles in total. Okay. So if you have 0.010 mole, so the total moles of oxygen gases are 2.5 into 2.5 into 0.010 is going to be 0.025 moles. Okay. Now this is the first part of the question. In the second part, we have room temperature. So 1 mole equals to 24,000 cm3. If we have 0.025 moles, how much volume we have? So multiply by 24,000 is going to be 600 cm3. So I believe B is going to be the correct answer. Okay. Question 22. V and Z both elements in period 3 in the periodic table. That's very, very important. That V and Z both are found in period 3 of the periodic table, which means both the element have in the same period. Each element forms one stable ion that does not contain another element. Okay. The atomic radius of each element and the ionic radius of the ion described above is shown. Okay. So these are the atomic radiuses. These are the ionic radiuses. So when we move from V to Z, atomic radius decreases. It is a period trend, and obviously across the period, atomic radius decreases. Okay. So first of all, across the period atomic radius decreases. First thing. Second thing, the size of ion is smaller than that of the neutral element, which means it must be a cation. Size of ion is smaller than neutral element. So must be cation. In another attempt, the size of ion is bigger than that of the neutral element, which means this must be the anion. Okay. Size of ion is larger or bigger than neutral element, that means it must be an anion. Okay. Oh my goodness. Which statement is correct? Ions of V and Z have the same number of full electron shells. That's absolutely incorrect, because whenever cation is formed, number of shells decreases. For instance, we have sodium, all right? It has an atomic number of 11, so it has 11 electrons. Let's configure it. 1s2, 2s2, 2p6, and this is your 3s1. So when you make it into cation, one electron is lost from the valence shell, which means this valence shell is lost also. So there will be no same number of shells. All right. So that's not going to happen. Next statement, ions of Z are positively charged. Not at all. Ions of Z are negatively charged. This is also incorrect. Next, Z has a greater electron negativity than V. Oh, if it is an ion, obviously it is non-metal. If it is cation, then it means it is metal. And you guys know that across the period, electron negativity value increases, which means metal have lower values of electron negativity and non-metals have higher value of electron negativity. That means Z has more electron negativity value than V. So this might be the right answer. Okay. Let's talk about option D. V has more outer electrons than Z. V is metal, all right, and Z is non-metal. So if it is non-metal, obviously it has more valence electron. If it is metal, it has less valence electrons. Group 1, group 2, and group 3 element, group 1 and group 2 elements are metals, and these metals have only one valence electron and two valence electrons respectively, right? Whereas group 5, 6, 7, 8 are non-metals, and these have more valence electrons, obviously. So this statement is absolutely incorrect as well. Okay. Whew. It's just tricky, bit tricky, but you should remember that if it is cation, obviously metal, it needs to be metal. If it is anion, then means it has to be non-metal. One more thing, metal, fewer valence electrons, and non-metals, more valence electron as compared to metals. Okay. Question number 23. In group 2 of the periodic table, the properties of the elements and their compounds show regular change down the group. regular change down the group. So which property shows a decrease from magnesium to barium? So when we move from magnesium to barium, thermal stability of group 2 carbonates and nitrates increases, which means decomposition takes place at higher temperature, and examiner is asking for the decrease, right? Which means option A and option B is incorrect, because decomposition takes place at higher temperature. Because decomposition occur at high temperature. So thermal stability actually increases. His examiner is looking for decreases, which is why A and B incorrect. Okay, let me sort that out again. Oops. Okay. Now the next option is the solubility of hydroxides. The solubility of hydroxides increases down the group. Obviously, C is also incorrect. The right answer is going to be D, because solubility of sulfates decreases down the group. And that's what the examiner was looking for. Decreases. That's an easy question. Down the group. Okay. Let's do 24. 4 properties of beryllium or beryllium compounds are listed. Which property is different from the property of magnesium or the equivalent magnesium compound? Okay. First, beryllium reacts with oxygen when heated in air. Magnesium does not. This is correct, but this is not correct. Magnesium can also react with oxygen and form magnesium oxide, which means A is going to be the incorrect answer. Okay. Beryllium reacts with aqueous H2SO4, all right, to form a metal sulfate and hydrogen gas. That's right. Magnesium does not. Magnesium can also react with acid to form salt and hydrogen gas, which means B is also incorrect. Beryllium nitrate decomposes on heating to form metal oxide, nitrogen dioxide, and oxygen. That's right. Magnesium nitrate does not. Magnesium nitrate can also decompose into magnesium oxide, nitrogen dioxide, and oxygen gas, which means this is correct, but this is not correct. Not correct. It is also incorrect. Guys, this is also incorrect. Okay. The right answer is going to be D. That's the only option left. Beryllium chloride reacts with water to form fumes of HCl. That's absolutely correct, because BeCl2, when reacts with water, it will turn to HCl. Plus BeO. Okay. Magnesium chloride does not. Magnesium chloride does not. Exactly. Magnesium chloride is basically an ionic compound. It is soluble in water. It cannot react with water. It is soluble in water. So that's the difference. Okay. Oh my goodness. Organic chemistry again. Okay. Organic chemistry. Let's solve organic chemistry here. First, read the question. Which two formulae correctly represents a pair of structural isomers? Let's talk about A here. I think A is same. Both these compounds are same. For option A, this is CH3, this is CH, this is CH3, and this is COOH. And CH3, CH, CH3, and then COOH. So both the structures are same. This and this is same cheese, which is why A is incorrect. Option B, CH3, CH, bracket COOH means I can write it here, and then CH3 here. It doesn't make any difference again. It doesn't make any difference. As long as it is attached, this group is attached to this carbon. So I can write this structure in this way as well. CH3, COOH. As long as this group is attached to this carbon, it doesn't make any difference if you write here or here. Okay. So this is CH3, CH, CH3, COOH. Again, both the structures are same. Again, incorrect. Option C. This is CH3. Oops. Incorrect option. Incorrect option. Because this carbon valency is not satisfied. The number of bonds of carbons are not satisfied in this option. And also these have 3 carbon atoms, whereas this have 4 carbon atoms. So for structural isomers, the molecular formula needs to be same, which is not actually correct in option C. C is also incorrect, and obviously we'll go for D. C, we have 4 carbon atoms here. We have total 4 carbon atoms. So both of them have same number of carbon atoms, which means both of them have same molecular formula but different structural formula. Let's talk about the structural formula of this. Option D. This is CH3, CH2, CH2, and COOH. And this is going to be CH3, CH, CH3. This is the chain isomer. And this is COOH. Yes, both of them have molecular formula C43579, C4H912O2. यहाँ पर भी C4H9O2. So both of them have same molecular formula but different structural formula, which means both of them are structural isomers of each other. Okay, much better. This is C4H9O2. Okay. Question 26. Which reagent and conditions would result in the formation of butane nitrile, also called cyanopropane? Butane nitrile is also called cyanopropane. Okay, first option. 1-bromobutane heated under pressure with ammonia in ethanol. It's going to be incorrect because this will give you aminobutane. Okay, this will give you this structure: CH3, CH2, CH2, 1-bromobutane, CH2, and then NH2. And we need cyanide, not NH2, which is why incorrect. 1-bromopropane heated with potassium cyanide in ethanol. So if I take 1-bromopropane like this, CH3, CH2, CH2Br, and let's suppose it is reacting with potassium cyanide in ethanol, and ethanol will serve as a solvent, obviously, under heated condition. So it will turn to potassium bromide and CH3, CH2, CH2, and then CN, and that's your butane nitrile, which is also called cyanopropane. And that's the exact structure we need to find out. So I think option B is going to be the correct answer for sure. Okay. Let's talk about C, propanol, heated with hydrogen cyanide. So if propanol is heated with cyanide, propanol is an aldehyde. When it is treated with hydrogen cyanide, it will turn to cyanohydrin. And in cyanohydrin, you will get OH and cyanide at the same time in the same structure, right? So that's not going to happen. That's not possible with this. So I'm not going to get butane nitrile with option C. Similarly, I'm not going to get butane nitrile with option D because propanol is ketone and ketone gives cyanohydrin. And in cyanohydrin, we have OH group as well, and there is no OH group in this structure, which means I cannot get butane nitrile from option C and D, okay? Which is why C and D is incorrect option. Question 26. Compound X C3H7Br reacts with hot alcoholic NaOH to produce two compounds Y and Z. When you say hot alcoholic NaOH, that means elimination takes place. Okay, elimination takes place. Elimination occur. This is your alkyl halide because of the presence of halogen. So when any alkyl halide undergoes elimination, always alkenes are formed, which means both of them are alkenes. On reaction with bromine, Y gives a product C3H7Br2. Obviously, if alkene reacts with bromine, this product is going to be formed, which exists as a mixture of 4 optical isomers. Again, 4 optical isomers are the key statement. 4 optical isomers is a key statement, and this statement is gonna help you to get the answer. On reaction with bromine, Z gives product this, which is non-chiral. This is also very, very critical statement, and I think it is not going to be easy. Not going to be easy. Not going to be easy. Elimination. We need to find out the elimination things. Okay. We need to find out the elimination things. Oh my goodness. I think I need to use this strips so that you will get the idea कि जी किस तरह से काम होगा, and I hope कि आपको ये पता तो चल गया है. मैं पहले जो है मैं स्ट्रक्चर लिख लेता हूँ इसका. This is Pr and this is CH3. Okay, let's solve this. My goodness, hold on. This question has a lot of working and we don't have any that much space. So I need to solve it for you. Now, elimination takes place from the hydrogen of adjacent carbon atom according to my lecture. This is going to be your adjacent carbon atom. And this is going to be your adjacent carbon atom. So elimination takes place either from this or from this. हम दोनों से बना के दिखाते हैं. Now this CH3 will remain as it is. And this is going to be your double bond. My goodness, I need more space actually, because I need to react with HBr as well. So that's not a good idea. Let's use some other page so that I can work it with peace of mind. Hold on a second. It's a lot of working actually. Okay. Now I can solve without any hesitation because I have space. So for A, for A, we have bromine here, we have CH3 here. Okay, so elimination takes place from adjacent hydrogen atom or hydrogen of beta carbon atom. So either elimination takes place from here or here. That means I'll get two different alkenes. Okay, so double bond is going to be formed between these two carbon due to elimination. And also double bond is going to be formed on this carbon atom. Okay, one more thing, double bond elimination takes place from the hydrogen of adjacent carbon atom. The elimination also takes place from this hydrogen atom. So if elimination takes place from this hydrogen atom, you will get what? You will get this structure. Okay, you will get this structure. That's a lot of information. Now अगर मैं इसको ब्रोमीन के साथ रिएक्शन करवा दूं तो obviously bromine attached to adjacent carbon atom. So first bromine is here, second bromine is here. Same, if I'll use bromine, obviously it will attach to adjacent carbon atom. One bromine is here, one bromine is here, and this is your CH3. Okay, so this is going to be your chiral, this is going to be your chiral. So you have 4 isomers from here. This is going to be your chiral, this is going to be your chiral, this will give you 4 isomers also, but obviously this won't give you no optical isomers, no chiral carbon. I think A is going to be the right answer. Why? Because one on the reaction with bromine, Z gives product which is non-chiral. So basically this Z is non-chiral. This is your Z, which is non-chiral. So option A gives you this answer, which means option A is the right answer because ये आपको 4 isomers भी दे रहे हैं और non-chiral भी दे रहे हैं. So I think A is going to be the right answer. Let's talk about B and obviously other stuff. Let's talk about B. Okay, in option B, we have CH2Br. So elimination takes place from the hydrogen of beta carbon atom. So this is going to be your hydrogen, which needs to be eliminated. So double bond exists between here and here. Okay. Now, if you add bromine in this structure, bromine are gonna attach on the adjacent carbon atom. First bromine is here, and second bromine is here. Now this is your chiral, and it gives you it gives you only one compound. All right. Whereas examiner is saying that we are getting 2 different compounds, which means this option is incorrect because we are getting only one compound. Okay. I hope it makes sense to you. Let's talk about C. That's a very crazy question. It has a lot of working actually. This is CH3 and this is Br. So elimination takes place from here and from here. Okay, either from here or from here, which means we are getting two different structures. One is this and one is this. Okay. Now, if we add bromine, it will attach to adjacent carbon atom. First one is here, second one is here. So this is going to be your chiral, this is going to be your chiral, this is your 4 isomers. One bromine is here and one bromine is here. Obviously it is also chiral, it is also chiral. So obviously 4 isomers from here as well. So we are getting 4 isomers, but we are not getting non-chiral. Non-chiral absent in option C, which is why C is incorrect. So I believe I was right. A is going to be the right answer. And obviously B is also incorrect. Okay. I hope it makes sense to you. That's a lengthy question. That question has a lot of stuff actually for working. When Ludin S is heated under reflux with an excess of acidified potassium dichromate 6, compound M is formed. What is the molecular formula of compound M? So first of all, you should understand that this is going to be your secondary alcohol. Okay. Next is your primary alcohol, which is also called 1-degree alcohol. Last but not the least is this, that is your tertiary alcohol. And you guys know that tertiary alcohol never oxidizes. So this will remain as it is, but obviously this will gonna change into ketone and this will gonna change into carboxylic acid because we are using excess amount of acidified potassium dichromate 6. All right, we're under heat reflux condition. So this is going to be carboxylic acid, this is going to be ketone, but this will remain as it is. And then we need to find out the molecular formula. Okay. Let's make the structure here. Okay. This is going to be a ketone. This will remain as it is. And this is going to be your carboxylic acid. Now we don't need to count carbon atom because carbon atom is same in all the options. All right, let's go over oxygen atom. 1, 2, 3, 4, 5 oxygen. So 5 oxygen is here, 5 oxygen is here. That means C and A is absolutely incorrect. Now let's count hydrogen atoms. My goodness, hydrogen is tough. Hydrogen is tough. This is your 1, this is your 3 hydrogen. Oh, 3, and this is your 1 hydrogen, 3 hydrogen, 2, and this 3. Let's count these hydrogens. 3, hold on a second, hold. 3 plus 2, 5, 5 plus 2, 7, 7 plus 3, 10, 11, 12, 13, 13 plus 4, 13 plus 3, 16, 16 hydrogen atoms. 16 hydrogen atoms is here. So right answer is going to be B, I believe. Okay. I hope it makes sense to you. Question 29. Cyclohexene C6H10 as a formula is a hydrocarbon with 6-membered ring of carbon atoms. Okay. That's the structure of cyclohexene, guys. That's what we have done in the class. It has several structural isomers that are straight chain alkene. Several structural isomers, straight chain alkenes. The number of double bonds in each of these molecules is P. What is the shape of the cyclohexene molecule? Again, shape of cyclohexene molecule. Again, shape of cyclohexene molecule. And what is the value of P? So we need to find out the value of P, and also we need to find out the shape of cyclohexene molecules. Guys, you know that this carbon is sp2 hybridized. This carbon is also sp2 hybridized. So both of them have planar geometry. But this carbon, this carbon, this carbon, and this carbon, all of them are sp3 hybridized. And since these are sp3 hybridized, obviously they have tetrahedral geometry. Okay. So these carbon atoms have tetrahedral geometry because of sp3 hybridization, which means the structure of cyclohexene is not planar. And obviously option A and option B is incorrect. Now competition exists between C and D. So we need to find out the straight chain alkene, which is the isomer of cyclohexene. Oh my goodness. So it's CH2 double bond CH, CH2, CH, 1, 2, 3, 4, CH2, CH double bond CH2. I think 1, 2, 3, 4, 5, 6 carbon. How many hydrogen atoms? 2, 3, 5, 7, 8, 9, 10. 10 hydrogen atoms. So cyclohexene has a formula of C6H10, and this isomer has also a formula of C6H10, which means the straight chain alkene must contain 2 double bond in order to get this structure or this formula, which means this value of P is basically 2. And I think right answer is going to be D. Right answer is going to be D. Okay. So I believe you have an idea. And obviously, if you need 2 double bond in the straight chain alkene, these double bonds, can be here or there, but you can write in this way as well. There are the multiple structures with this. These are the different possible structures, like this also, CH2 double bond CH, CH double bond CH, H2, and this is CH3. It is also C6H10. So these are the multiple structures or multiple isomers of straight chain alkane. Either you can use this one or that one. The number of double bond will remain same, that is P. Okay, that is 2. Right? 1, 2, 3, 4, 5, 6, right? 3 plus 2, 5, 6, 7, 8, 9, 10. I'm right. So because of these sp3 hybridized carbon, the structure of these carbon atoms are tetrahedral, whereas the structure of these 2 carbon atoms are planar, which means the structure of cyclohexene is not exactly planar, it is non-planar, and therefore either C or D can be the correct option. And since we have 2 double bond in the straight chain alkene, which means D is going to be the right answer. I hope it makes sense to you. Let's move on to the question number 30. Exhaust gases from an internal combustion engine are made less harmful by passing them through a catalytic converter. A number of reaction takes place in the catalytic converter. Two such reactions are described in the table. Which row is correct? There are three different structures actually takes place in the catalytic converter. The first one is oxidation of CO into CO2. That's your oxidation. The second one is reduction of NO into N2. Okay, and also the unburned hydrocarbons. So if you have an unburned hydrocarbon like CXHY is the general formula, and if you introduce into the catalytic converter, it will oxidize into carbon dioxide and water. So basically in catalytic converter, we have oxidation and reduction. Let's talk about this option, type of reaction that removes carbon monoxide. So carbon monoxide is removed by oxidation. So oxidation and oxidation. That means option C and D is incorrect. Now the next is the type of reaction that removes unburned hydrocarbons. Unburned hydrocarbons are removed through oxidation. So oxidation is here and here. And obviously right answer is going to be an A. Okay, that's an easy stuff. Question 31. Which compound reacts most rapidly with aqueous silver nitrate by SN1 mechanism? Number one, examiner is looking for the most rapid reaction. And most rapid reaction means the weakest bond. Is always followed through weaker covalent bond. The weaker the covalent bond, the easier to break that bond, and the reaction takes place most rapidly. All right. And the most important thing is SN1 mechanism. So guys, SN1 mechanisms always takes place via tertiary alkyl halide. Takes place through 3-degree alkyl halide. Oh God. So obviously, this compound has carbon-chlorine bond. This compound has also carbon-chlorine bond. This compound has carbon-iodine bond. This compound has carbon-iodine bond. And obviously, carbon-iodine has a larger bond length than carbon-chlorine, which means carbon-iodine is a weaker covalent bond than carbon-chlorine. And that means carbon-iodine bond needs less amount of energy to break this bond. And therefore, a reaction takes place most rapidly with carbon-iodine instead of carbon-chlorine. And therefore, option A and B is incorrect. Now we need to find out from these two options which one is tertiary alkyl halide. I believe D is going to be the tertiary alkyl halide. Let's make the structure of D first. We have propane, one. My goodness, we have propane, so we need to make 3 carbon atoms. We have 2 iodo, that means second carbon has iodine. We have 2 methyl, that is CH3. So that is going to be a tertiary alkyl halide, obviously. And this is SN. This follows SN1 mechanism. Okay. This follows SN1 mechanism because it is tertiary alkyl halide, which is why D is going to be the right answer. Guys, 1 iodo methyl propane is basically your primary alkyl halide. Let's make this a structure. Oops, I don't have any space. 1 iodo methyl propane. 1, 2, 3. 1 iodo. 1 iodo means iodine is attached to the first carbon. Methyl propane means second carbon has methyl group. And obviously you can see it is primary alkyl halide. It is 1 degree alkyl halide. and 1 degree alkyl halide always undergoes SN2, not SN1 mechanism. Okay. So obviously this is going to be the correct answer. Next, question number 32. Tartaric acid is found in many plants. A sample of tartaric acid reacts with an excess of lithium aluminum hydride to form an organic product J. What happens when NaOH is added to separate sample of tartaric acid and J? First of all, this is your tartaric acid. Let's make this structure first. Uh, okay, this is the structure of tartaric acid. It's such a huge structure. No issue actually. This is COH. This is CHOH. Again CHOH. And then COH. If I'll use NaOH, because he's adding NaOH with a sample of tartaric acid. So what is going to be the structure? What is going to be formed? Basically a salt, because all alcohols are neutral. So alcohol won't react, but carboxylic acid can react. Okay. So tartaric acid can react. Tartaric acid can react. That is the second part of the question, which we have discussed. Let's talk about the first part of the question, that we need to use lithium aluminum hydride. If you use lithium aluminum hydride, obviously these carboxylic group will turn to primary alcohols because of reduction. So this is your COH, CHOH, CHOH, and this is your COH. If I'll use lithium aluminum hydride, obviously it will turn to primary alcohol, that is CH2OH, then CHOH, then CHOH, and then CH2OH. Okay. Now all alcohols are neutral. Obviously, if you try to react this compound with NaOH, there will be no reaction. Okay, because all alcohols are neutral. So only tartaric acid can react with NaOH, not this. And this is your J. So J cannot react with NaOH. Only tartaric acid can react. The right answer is B. Okay. Question 33. Citric acid can be converted into tricarbolic acid in 2 stages and intermediate QS form. Which reagents are needed for each stage? Okay. Now guys, look, this part of the structure and this part of the structure is still same. All right. Only changes is that this OH removes from here. Okay. And the second change is you will find H here. So what we can do is we can remove water from here. And for the removal of water is basically dehydration or elimination. And for that, we need concentrated sulfuric acid. Okay. So either concentrated sulfuric acid, option C and D is absolutely incorrect. So we need to remove water from stage 1. And that's dehydration. So let me remove this. If I remove these two, obviously a double bond exists between these two carbon. So let me make the structure of Q. This is going to be CH, double bond C, CWH, CWH, and this is CH2, CWH. Now from this Q, I need to make this one. So this structure will remain as it is. It has no changes. This CWH and this CWH will remain same without any issue. Now look, how many hydrogen atoms here? 1. And how many hydrogen atoms here? 3. Which means we need to add 2 more hydrogen atoms, right? And for that we need hydrogen molecule. And hydrogen molecule always undergoes hydrogenation process. And for hydrogenation, we need hydrogen in the presence of nickel catalyst, which means A is going to be the right answer. Smooth explanation. See guys, this part of the structure and this part of the structure is same in this reaction. But the issue is that we don't have OH in the product. Also, this carbon has hydrogen atom. So how can we go about this reaction? Basically, we need to remove water from here. So when we remove water, that's called dehydration, also called elimination. Dehydration or elimination always takes place via concentrated sulfuric acid. Iska matlab step 1 needs concentrated sulfuric acid. So either option A or option B is going to be the correct option. Obviously, C and D is incorrect. Now, what is the structure of Q after the removal of water? This is the structure of Q after the removal of water. Now look at, you need to compare the structure, this and that, with each other. Now you need to compare the structure of Q with the structure of product. All right. Look, this CWH remain as it is. This CWH remain as it is. This whole group will remain as it is. So what is the basic changes actually? Basic changes is that you have only one hydrogen with this double bonded carbon. Whereas in this structure, we have total 3 hydrogen atoms. Iska matlab we need to add 2 more hydrogen atoms. And if we want to add 2 hydrogen atoms, which means we need 1 molecule of hydrogen molecule. And therefore, this step is going to be hydrogenation or addition of hydrogen. And for that, we need a nickel catalyst. So either A or D, and obviously the A is going to be the right answer. I hope it makes sense to you. Structural and stereoisomerism should be considered when answering this question. P has a molecular formula this. P undergoes an orange precipitate with 2,4-DNPH. P undergoes orange precipitate with this. Iska matlab, that means P can be aldehyde, P can be ketone. All right, because 2,4-DNPH test only comes positive in aldehyde and ketone. So question is, how many isomeric structure does P have? So first of all, we need to make aldehyde, and then we need to make ketone, and then we need to decide how many structures we can get from this. Again, tricky part of the question, but it's all right. We have 5 carbon atoms. My first structure is CH3, CH2, 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 CHO. Now we have hydrocarbon chain, which means we can have chain isomerism in this. This is CH3. This is CH3. This is CH2. This is CHO. Now in the third, this is CH3. This is CH2. This is CH, CH3, and then CHO. All right. Now what I did is I have shifted CH3 to this carbon atom so that I'll get this isomer. Okay. There are 3 isomers of aldehyde. Now let's make ketone. 5 carbon atom ketone. CH3, CO, CH2, CH2, CH3. This one is 4th. Let's make 5th one. I'll shift CO to this, to here, to this carbon atom. So it's the positional isomer actually. CH3, CH2, CO, CH2, CH3. Since we have hydrocarbon chain, I can use chain isomer 6 CH3 CO, CH, CH3, CH, CH3, and then CH3. 1, 2, 3, 4, 5. Okay. So we have 6 altogether. Okay, I can make one more. Oh, yes. Wait. Nothing is wrong. Let me work on it. If I'll shift this CH2 to this, I'll make another. That is going to be my fourth one. CH3. Okay, CH3. CH3. This becomes CH3 after the shifting, and this will remain CHO. This is fourth. Fifth, sixth, seventh. Anything left? 7, 7. Oh yes, I did only structural isomerism. Okay, now I need to consider stereoisomerism. And stereo, let me explain it. These are the structural isomers of aldehyde 1, 2, 3, and 4. These are the structural isomers of ketone 1, 2, 3, and 4. Okay, the total structural isomers for aldehyde and ketone would be 7 so far, and all of them are aldehyde and ketone, which means they can easily react with 2,4-D and pH to give orange precipitate. All right. Now, so far I have discussed the structural isomers. So far. I need to consider stereoisomerism. There is no geometrical and optical isomerism here. There is no geometrical and optical isomerism possible here. There is no geometrical and optical here. There is no geometrical optical. There is no geometrical optical. There is no geometrical optical. But yes, we have one chiral carbon atom here. So total we have, I think, 8 isomers along with chiral. Okay. So 2 to the power 1 is going to be 2. So 2 optical isomers because of one chiral. So 1, 2, 3, 4, 5, 6, 7, and this one is 8. मैंने इसको 1 लिया है. 1 क्यों ले रहा हूं मैं इसको? क्योंकि मैं इसका स्ट्रक्चर ऑलरेडी बना चुका हूं. Okay. So this is going to be 8. 2 isomeric alcohols. W and X have molecular formula C4H9OH. Okay. C4H9OH has 4 different possible structural isomers. The first one is CH3, CH2, CH2, CH2OH. Okay. The second one is CH3, CHOH, CH2, CH3. The third one is CH3, CH3, CH3OH. And last one is CH3, CH, CH3, CH2OH. So these are the 4 possible structural isomers of C4H9OH. All right, so far. Let's read the question again. W is oxidized to carbonyl compound. So obviously this is not going to be the correct option because tertiary alcohol never oxidizes. Okay. Why which gives a red precipitate with Fehling solution? That means it is an aldehyde. And aldehyde is always formed through primary alcohol, not secondary alcohol. Okay. So W needs to be primary alcohol. Because W being a primary alcohol, when oxidized, it will turn to an aldehyde, and aldehyde gives positive test for Fehling reagent. Okay. Next is X is oxidized to carbonyl compound. Z which does not gives red precipitate with Fehling solution? Which of W and X gives a yellow precipitate with alkaline aqueous iodine? Alkaline aqueous iodine gives you test if CH3CO group is present or CH3CHOH group is present. That means W is an alcohol which contains CH3CHOH group, so that you will get a positive test of iodoform, and this is the structure of an alcohol which has CH3CHOH group, and this alcohol gives you positive test of iodoform. Okay. So this is the structure, guys. CH3 CHOH CH2 CH3. So this is your X, because this structure has CH3 CHOH group. This will give iodoform ka positive test. Gives positive test of iodoform. Okay. And when you oxidize it, obviously it will turn to ketone, and that ketone is CH3 CO CH2 CH3, and this has also CH3CO group, so this will give you iodoform positive test, and that is going to be your Z. Okay, and this Z won't give you Fehling test. Okay, so X is his. This will give you positive test. When you oxidize it into ketone, it will give 240 NPH ka positive test, but won't give Fehling test. But this will give you positive test of iodoform as well. Positive test of iodoform. Okay. Which of W and X gives a yellow precipitate with alkaline aqueous iodine? Actually, X and W. So only X gives positive test of iodoform, and therefore C is going to be the right answer. Okay. X and Z both gives positive test of iodoform, but according to the option there is no Z, so we need to go for X only, and therefore C is going to be the right answer. Okay. That's a tricky question actually. Question number 36. The ester ethyl butanoate can be hydrolyzed using an excess of dilute sodium hydroxide. That's an alkaline hydrolysis, guys. Alkaline hydrolysis. Okay. This is the alcohol part according to my lecture, and this is the acid part according to my lecture. Okay. That was the alcohol part, and this was the acid part. Now the question is, which substance is a product of this reaction? Ethyl butanoate. Butanoate is this CH3 CH2 CH2 CO. That is your butanoate, and alcohol part is this O CH2 CH3. So when you hydrolyze it, the ester bond will break, and you will get what? You will get acid, and obviously alcohol, ethanol and butanoic acid. Now we have alkaline medium. So when we use alkaline medium, it will give you salt. Alcohol will remain as it is. That's what we have discussed in the class, if you remember. So right answer is going to be an A. Okay. Next question, question number 37. Seems like it's related to calculation. Okay, no issue. An aqueous solution contains 4 grams of carboxylic acid Q. When this solution reacts with an excess of magnesium, okay, 380 cm cube of gas is produced measured at STP. Guys, few things. Magnesium has to be in excess. Magnesium is in excess, which means it is not a limiting reactant. Ultimately, carboxylic acid is the limiting reactant. Okay. The carboxylic acid is the limiting reactant. Okay. Hold on. Limiting. My writing really bad. Limiting reactant. Second thing, examiner has given you STP, not RTP. You need to be careful. STP volume is 22.4 dm3. I think this STP volume is also given in at the end of the paper. This is the volume at STP. So we need to use this volume, okay, instead of 24 dm3. So in cm cube, I think it's going to be 22400 cm cube. Okay. So I'm gonna use this for sure. इसको हम 22400 cm cube कर लेते हैं. So first of all, we have a carboxylic acid. We don't know the structure of that. So let's suppose we have RCWH. It is reacting with magnesium, converting into salt, which is this, and hydrogen gas. Now we know the volume of hydrogen gas. We know the volume of hydrogen gas. So first of all, we need to find out the moles of hydrogen gas. So basically it's 380 divided by 22400 cm cube. So it's going to be 380 divided by 22400 is going to be 0.0169 moles. See guys, we need to balance the equation. Why? Because we have 2 moles of RCW, which means we need to put 2 here, and now the equation is balanced. And according to balanced equation, acid and hydrogen gas has a ratio of 2:1. You can see in the equation, right? So if we have 0.0169 moles of hydrogen gas, what is going to be the moles of acid? We need to multiply by 2. You will get 0.033. 0.0339 moles. Okay. Now in the next, we know the mass of carboxylic acid. We know the moles of carboxylic acid. We can find the MR. So MR, in order to find the MR, we need to divide mass by moles, which is 0.0339. So guys, 4 divided by moles is going to be 117.89. So it's going to be 118 roughly. So 118 is where? In B. B is going to be the right answer. Okay. In the next question, the infrared spectrum of an organic compound is shown. Okay. Which compound could give this spectrum? Okay. Now in this spectrum, we have this peak and it appears at 3000 centimeter inverse, not broad. So CWH absent. Obviously, alcohol is also absent. 3350 centimeter inverse. So alcohol absent, carboxylic acid absent. But over here we have 1700 centimeter inverse, that is carbonyl group present. So if carboxylic acid is absent, which means this option is incorrect. If alcohol is absent, which means this option and this option is also incorrect because both of them are alcohol, right? Only C is going to be the right answer. That is ketone. That is carbonyl peak is there. All right. That's a very easy question. If you won't get carboxylic broad peak, if you won't get alcohol ki strong peak at 3350 centimeter inverse, obviously there is no OH. If there is no OH, obviously option A is incorrect, option B is also incorrect, option D is also incorrect because of the fact that it has alcoholic functional group, and obviously C is going to be the right answer. Let's move on to the question number 39. Cyclohexa 1,4-diene is treated with a solution of bromine in tetrachloromethane in the dark. Which product is formed? Obviously, when you react this compound with bromine, double bonded carbon atoms, bromine is added on the double bonded carbon atom. So one bromine is here, second bromine is here. Similarly, one bromine is there, second bromine is here. So this is going to be your product, and this product is given in option B, and therefore B is going to be the right answer. That's easy question. Last question. 2-methyl butene is reacted with hot concentrated acidified potassium magnate 7 solution. What are the product of this reaction? Hot concentrated KMnO4 reaction. So let's draw the structure of 2-methyl butene. Butene. 1, 2, 3, 4 carbon atom is but, and 2-ene means second carbon atom has double bond. 2-methyl means this carbon has CH3. This carbon has also CH3. This carbon has CH and this carbon has CH3. Now, when you react this compound with hot concentrated KMnO4, obviously this CH is going to be CWH. So CH3 will remain, and this CH will turn to CWH. I hope it makes sense to you. Okay. On the other hand, we have this compound. All right. And this double bonded carbon has no hydrogen, which means it will turn to ketone according to my lecture. So this CH3 will remain as it is. This will turn to ketone. Okay. So this is going to be your ketone. The whole structure will remain as it is. Okay. Only oxygen is there. So we have ethanoic acid as a product. So where is ethanoic acid? Ethanoic acid is here. Ethanoic acid is here. So A and D absolutely incorrect. We have propanol. 3 carbon atom ketone is basically propanol. So where is propanol? Propanol is here. Propanol is here. So B is going to be the correct option. Okay. That's the end of this paper. Hope it makes sense to you. Thank you very much, guys.